So today we're going to look at graphing sine and cosine functions. So we've been talking about sine and cosine just on your unit circle itself. But now if you look at the grid that's in the middle, we're actually going to graph this on your x and y coordinate plane. So I'm going to actually have you guys fill in this chart. But before you get intimidated, understand that you guys already know, for instance, from 0 to 2 pi, because that's just the lines on your unit circle. So in this space that I have over here, I'm just going to create a unit circle. It's not going to be anything fancy. It's a little more like an egg, but I'm going to go ahead and label my unit circle. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. And if you go all the way around in a counterclockwise motion, you'll get to 2 pi. I just need to know what are the intersections or the coordinates at each of these purple dots that I'm bubbling. We've been doing this for weeks, so you should know that at 0, this is the coordinate 1, 0. At pi over 2, this is the coordinate 0, 1. At pi, this is -1, 0. And at 3 pi over 2, this is 0, -1. Since we're graphing the sine function, is sine the x or the y coordinate? It's your y coordinate. So for each of these, especially just for this first graph, I'm only going to focus on the y coordinates. So in your y coordinates, you're not going to do anything too crazy. I'm going to try to see if I can fit this in to the view, which I can now. At 0, what's your sine value at 0? 0. It's just 0. So we're just going to take those highlighted numbers and fill them in. At pi over 2, which is this guy here, your sine value is 1. At pi, your sine value is 0. 3 pi over 2, your sine value is -1. And at 2 pi, your sine value again is at 0. Think about it. How would I get the negative radians? So negative pi over 2 to -2 pi? Opposite direction, which way? Counterclockwise or clockwise? Clockwise. So we would just keep going in a clockwise motion to actually get the negative angles over here. So this would be, so I can actually write this right. This is negative pi over 2. This will be negative pi. This will be -3 pi over 2. And this guy down here, I have 0, 2 pi, and I'm also going to include a -2 pi. I know it's a little small to see, but that is a -2 pi. So the good news is we already know all of the y values. So let me put both of these back in one screen. Negative pi over 2 is going to show up as -1. Negative pi is going to show up as 0. -3 pi over 2, which is the same place as pi over 2, is 1. And -2 pi is the same as 0. So if you take a second, like I said earlier, and if you look at the coordinate plane, the x-axis is all in radians. The y-axis isn't. So all of these radians that I have labeled here for my x-axis, I can actually graph these now. The only thing I need, I look at all of the y values and I notice I have 0, 1, 0, -1, and then those numbers repeat. So let me actually graph this as +1 and -1 for this little second hash mark. And let's go ahead and plot these points. So I'm going to zoom in just a bit, and I'm going to plot all of my points. So I'm going to start from the positive interval on the x-axis. So we're going to start at the origin, 0, 0. We're going to go to pi over 2, 1. Pi and 0. 3 pi over 2, -1. And we're going to go to 2 pi, 0. Before you start connecting these as just a straight line, I want you to clearly understand that sine and cosine graphs need to be a curve. So don't just connect the lines like it's connect the dots. You're just going to curve this way and this way. Just like this. I want to see this graph be very curvy. Notice at the end, past 2 pi, I kind of continued this graph going up because I could continue on to literally positive infinity on this side, but we're just graphing it up to 2 pi. Let's do the same thing on the negative side. This time we're going to graph from negative pi over 2 to -2 pi. So negative pi over 2 is at -1. Negative pi is at 0. 3 pi over 2, -3 pi over 2 is at 1. And -2 pi, again, is at 0. On the left side of this graph, we're going to do the same thing we just said. We're going to make this graph very curvy. So pay attention to the curve that I'm giving this, so you have the same thing on your paper. All right, so while some of y'all are finishing up that curve, I'm going to call on a few of you guys, and I just want you to answer the questions I have. These 7 questions are really going to be important with helping you understand what the graph looks like and how to graph it and identify things in the future. So Jorge, what is the domain for this purple graph? All real numbers, perfect. We could also write that from negative infinity to positive. But yes, all real numbers is perfect. What's the range, Jorge? -1 to 1. And are those inclusive or excluded? Sorry, included. So included or not included? I feel like that's inclusive too. Okay, the next part is for sine. Sine is a blank function that is symmetric to something else. Okay, so when I have this first blank here, I'm asking if this is even or odd. Is this function even or odd? You saw that back when you were in Algebra 2. I can see your faces now. You don't remember. And we also talked about it at the beginning of the school year. So let me refresh your memory because I know y'all forgot. Okay, if a function is even, that means it's symmetric to the y-axis. I don't know if you can tell, but this page is kind of folded. What we literally did to see if it was symmetric to the y-axis is we folded the graph in half to see if it reflected onto the other side. I know since I'm on the document camera, it's a little difficult to see, but we're going to do the same thing for this curve here. So I'm going to go ahead and fold this graph over across the y-axis to see if it is symmetric to the y-axis. I don't know if you can tell, but this graph kind of goes up here. I could see one part of it, and then I also see that the other part go down like this. Is this showing that it's symmetric to the y-axis? If it was symmetric, what would it be? It would be overlapping. It would be right on top of itself. So unfortunately, this graph is not even. Okay, it's probably going to be odd, but let me make sure you understand what odd means. Odd functions are symmetric with respect to the origin. That means we can flip the image upside down and it will appear the exact same. So on this graph, just take a second and look at it as it is for sine. The graph is going to curve up first and it'll curve down here. So curve up to the right-hand side, curve down to the left. If I was to flip this graph upside down, it's still curving up to the right and down to the left. So that's what makes it an odd function. That is something we talked about at the beginning of the school year. So this is odd. Odd means that it is symmetric to the origin. That's why we're able to just flip that graph upside down. This next one for number 4, this might be a little new for you. It says the sine function is periodic if the period is blank, which means it repeats itself after that. Okay, so there's a specific value that I need in this blank. Periodic means, or a period means, that after a certain number along the x-axis, that same curve will start to repeat itself. So we're going to break this up into little chunks. Let me just first look from 0 to pi over 2. Okay, notice that that curve is going up to the right from 0 to pi over 2. If it was periodic from 0 to pi over 2, from pi over 2 to pi, you would see the curve do this. It would curve up this way. Is that what the graph is doing from pi over 2 to pi? No. Okay, so let me erase that. That's not what it's doing. Let me look back at the graph. Okay, from 0 to pi, we have a dome going to the top. Okay, well, if that's going to be the same, if it's going to be periodic just up to pi, I should see from pi to 2 pi that same top dome. Do we see that? Okay, so you guys tell me, where will it be periodic? From what to what? 0 to 2 pi. This whole piece is one big period. It's one cycle. After, that's why I purposely had this going up. Well, one was to help Jorge with labeling the domain, but this little arrow going up means it's going to repeat itself. This curve is going to keep going up. It's going to come back down and then go back up. It's going to follow that exact same shape after 2 pi. So the period here in this middle part for question 4 is 2 pi. After 2 pi, it will repeat. And I'm going to kind of bold this all together. All of this is one cycle, if I could spell cycle correctly. There we go. 1 cycle. 5, 6, and 7, you've already seen before. Euridio, how many x-intercepts does this function have? It has 5. So ignore that list 4, and I want you to tell me what are the 5 x-intercepts. Read them out to me. Okay, so positive 2 pi. Next one.
Negative 2 pi, 0.
Okay, keep going.
Pi, 0, 0, 0.
Okay, so the origin.
And pi.
And regular pi. Yep, that works. All of those are your x-intercepts. Euridia, what's the y-intercept for that graph? 0. It crosses at the origin. All right, Euridia, I'm going to bother you for a little more. What's a maximum? Think back to Algebra 2 and Algebra 1. What's the maximum?
The bottom.
Okay, so the bottom isn't the maximum. That's the opposite of maximum. What's the opposite of maximum?
Minimum.
This is a minimum. And so is this one. So on this graph, what's the maximum going to be?
The top.
Yep. It's the highest points on your graph, guys. It's the highest points on your graph. So, Euridia, what is the maximum value? What's that y value where your maximum is? 1. So y is going to equal 1. And it occurs at what x values? So look at the x values that these maximums occur. What are they?
Negative 3 pi.
Over what?
Over 2.
And?
2 pi. I mean, pi over 2.
There we go. Pi over 2. And then for the last one, for minimums, she already helped me with minimums. So my y value for minimums is going to be negative 1. And it's going to occur at all of the x's that are at negative pi over 2 and 3 pi over 2. So negative pi over 2 and 3 pi over 2. So I'll give you a second just to copy that if you need to. And if you know what you're doing and you're ready to start with that second graph, go ahead and graph. You don't need me in order to create that graph again. So use the unit circle from the top, and we're now going to graph this for cosine instead of sine. We're going to do the exact same process. All right, so I'm going to move this over just a bit. I'm going to recreate my whole little unit circle that I had at the top. You can literally recopy the exact same things. This point up here, oops. Let's try that again. This point is at pi over 2. This was at 0. This is at negative pi. Ooh, not negative pi. Let's just put pi. This point will be at 3 pi over 2. I'm just putting in all of the positive counterclockwise radians right now. And I'm going to also recopy the coordinates. I'm literally recopying the exact same coordinates, so that way I have them down here. Melissa, is cosine the x or the y coordinate? It's the x coordinate. So I'm only going to focus on the x coordinates from my little unit circle. We're going to take those x coordinates and we're going to fill them in over here. I'm going to have to zoom out again. Over here in my chart. Let's focus just on 0 to 2 pi first, and then we'll graph the other side. So at 0, when your cosine is 0, your value is positive 1. I know you're like, well, Miss Tapia, it's the x coordinate of your circle. I get that. But I'm just asking for when your x value is 0, when cosine is 0, what's the value you're going to get on your unit circle? That's all. So at pi over 2, I'm going to take that highlighted 0. At pi, negative 1. 3 pi over 2 will have 0, and at 2 pi, we'll have 1. We're going to do the exact same thing, but we're going to go in a clockwise motion. So this is the same as negative pi over 2. This is the same as negative pi, and this is the same as negative 3 pi over 2. 0 and 2 pi are at the same place as negative pi over 2. Y'all already know. This negative pi over 2 is struggling because I barely fit it in. So this is a negative pi over 2 in this little corner. All right, let's go in a clockwise motion and let's get all of the radians with their y values. Well, technically the x coordinate from your circle. So we're going to take 0 for negative pi over 2, negative 1 for pi, 0 for 3 pi over 2, negative 3 pi over 2, and 1 for negative 2 pi. When you have all those points, go ahead and plot them on your graph. Remember, this is a curve. I labeled that word curve underneath cosine at the top, so make sure you make this a curvy graph. Again, I'm going to start with the positive. So we're going to start at 0, 1. Oh, this is 1. This will be negative 1. We're going to start at 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi, 1. Just like we did before, I'm going to make this as curvy as possible. It's going to be a little obnoxious, but we'll be all right. On this side over here, notice that I'm making this graph go down. So keep in mind I'm making this curve go down on the other side. I'm going to plot my negatives, and then I'm going to go ahead and create the curve on the left. All right, Melissa, what's the domain for this graph? It's still all real numbers, like Jorge told us earlier. And what's the range for this graph? Negative 1 to 1. And those are closed circles, so we're including those values. Now we need to see what type of function cosine is. So is it going to be even or odd? Well, the last question was odd, so I'm assuming this would be even, which means, if you look back at your notes, that this would be symmetric to the y-axis. So if we fold our paper in half along the y-axis, we should see that exact same curve line up. So remember, we tried to make this curve as curvy as possible. I'm kind of pressing as hard as I can. Hopefully you can see it. It's pretty much right on top of itself. I made some curves bigger than others, but it's expected to be right on top. So this curve here for cosine is actually going to be an even function, which means that it's going to be symmetric to the y-axis. It's not going to be odd, because if we were to flip this upside down, it would not be the same. All right, let's talk about that period one more time. So in order for it to have your period that goes from starting to repeat itself after a certain time, we're going to look at each piece individually. So from 0 to pi over 2, it has that curve going down. From pi over 2 to pi, it should have that same curve going down. It doesn't do that. As you go along here, what is one full period going to be? 2 pi. After 2 pi, that little curve down here going down means that this whole curve is going to start again. So look up. It's going to go down. On the other side, past 2 pi, it's going to reach some minimum and then curve right back up, just like it did. So it's going to keep doing that on every single side. So let me highlight this portion here, and I'm going to write this underneath that this is one full cycle. And then for item number 4, this is the same period, which is 2 pi. Jesus, how many x-intercepts does this blue graph have? It has 4. What are the 4 x-intercepts? Read them out. Positive or negative? Okay. You already said negative, so we'll go positive. But yes, you're right. So negative and positive, 3 pi over 2, and then negative and positive, pi over 2. That works. One more question. What's the y-intercept, Jesus? Where does it cross the y-axis? At 1, 0, 1. So it's up here right on the y-axis. That's at 0, 1. Just like Euridia helped me with on the last one, we do have maximums and minimums. The maximums are at the top, and the minimums are at the bottom. So again, especially since Melissa helped us with that range, she said it's between negative and 1 and positive, that's going to help us with our maximums and minimum values. So our maximum value is at y equals 1, positive 1, and it has these maximum values at negative 2 pi, 0, and positive 2 pi. It says to list 2, but they're technically 3. So ignore that list 2. And then for my minimum values, there's 2 minimums down here. So y equals negative 1. And your minimum will occur at negative pi and positive pi. These are your graphs. When you're ready, flip this over to the next page. You definitely want a highlighter nearby because we're about to highlight some stuff. I am going to be flipping back and forth, just a heads up, so please don't be surprised if you see me flipping the pages a lot. Okay, so let's talk about some terms. These terms that I'm highlighting, some of you guys have probably never seen before, and it's okay, but it'll help you with understanding what we're going to do next class with actually graphing these sine and cosine functions. So the two functions that we have on the first page, these are your parents. This is the parent sine function, and this is the parent cosine function down here. We're going to take this and talk about what the transformations will look like. So we have the first definition, which is a vertical shift. Y'all should remember this from Algebra 1. A vertical shift is just moving your graph up and down. Specifically though, especially since these curves are very like loopy and curvy all along the x-axis and y-axis, we need to actually identify what a center line and a midline are. Center line and midline are actually the exact same thing, but what it does is it helps you identify pretty much where the middle of that curve is. In order to calculate your curve, it's a horizontal line, or excuse me, the center line or midline. In order to calculate that line, you need to go halfway between your maximum and minimum values. So your midline is exactly halfway between your maximum and minimum values. So before we do any of these four questions, flip it back to the first page and let's find the midline for your sine and cosine parent function. So for your sine function, we have a maximum here, we have a minimum here. Remember, it goes along the y-axis, it's just between -1 and positive. So I just need to count how many units this is and take half. So this whole function is going 1, 2, 3, 4 units. That's how long it is. What's half of 4? So if I go 2 units down from my maximum, this line will be your midline. So I'm going to graph this out in orange, just a different color. It doesn't have to be orange. But this line that I just drew, I'm going to write in red. This is your midline. And that midline, ooh, what's the equation for that? Think back to Algebra 1. Y = 0. Thank you. Y = 0. For your parent, it should always be at the midline should always be at y = 0 for either parent. Let's confirm that with cosine. So again, I don't know for sure. I'm pretty sure it's the midline is the x-axis, but let's check. From your maximum to your minimum, they're both between -1 and positive. We're going to count 1, 2, 3, 4. Half of 4 is 2. The x-axis will be your midline. So this is your midline, which is again y = 0. So pretty simple. If you can add and divide by 2, you can get these midlines. So now on A, B, C, and D on the next page, I want you to identify what are the midlines and graph it out. Make sure after you graph them that you actually write what the equation is. So let me flip this back to the front and show you just for example with example A. Here's your maximum at the top. Here's your minimum. Okay, so it's between these two values on the y-axis. It goes down 1, 2 units. Half of 2 is just 1. So from the top down, we're just going to have 1 unit. Hussein, what's the equation for this line? Y = -2. Do the same thing for the other 3 graphs, guys. It's the exact same. Heidi, what's the equation you got for graph B? Y = positive or -3? +3. What about C? Y = 1. And then what about D? Y = -2. That's it. All of those equations we just wrote in red and highlighted in orange, those are your midlines. That's going to go straight through the center of your function, that curve. So the next part of this that we haven't talked about, but we technically have, is called the vertical displacement. Vertical displacement, guys, is literally just a shift. That's all it is. You learned how to do this back in Algebra 1 and Algebra 2. So in order to find a vertical displacement from a graph, the first thing you need to do is find the midline. Oh, good. We found that all for orange on all of the problems. Next, we're going to count how far from the midline it is to the x-axis. Okay, well, I want you to keep in mind, if you count above the x-axis, so for instance, like B and C, these displacements are going to be positive. So that means it's going to move in a positive direction up your graph. If you count below the x-axis, your vertical displacement is negative, so like A and D. So what this means is, if you were looking at the transformation, because both of these parents had a midline at 0, both of them did, their displacements, their shifts, are either going up or down. So for this graph here, if it initially started on the x-axis, it's going down 2 units. So down 2 units. That means that the next one, B, this one went up 3 units. That's why it's y equals 3. So this is up 3 units. For C, that went up 1 unit. And then D went down 2 units. Really quick, before we do the rest of these, look at these middle, the A, B, C, and D that we just did, and look at the A, B, C, D for the next one. What do you notice? They're the exact same. So what I want you to do for all of the rest of these questions on this page, I want you to take whatever highlighter you used, and I want you to highlight where the midline is. This will save us some time later. Make sure you're careful, guys, especially on that last one. -2 could be kind of hard to find. So make sure you graph your midline correctly. Okay, the next section isn't a vocabulary term, but it is going to help us with identifying which graphs are sine and which graphs are cosine. So it does ask you to look at your y-intercept. So for each of these graphs, we're going to bubble where our y-intercept is. This purple dot is going to show where my y-intercept is for every graph, just for this middle section here, just for A through D. So in order for you to have a sine graph, sine is at the intersection of the y-axis and your midline. So Joseph, if you look at all 4 of these graphs, which of these graphs have an intersection with the y-axis and your midline? So pretty much the y-intercept and that orange line I just drew. Which graphs? Not quite. Intercept of the y-axis, which is the y-intercept, and your midline. So if we want to put y instead, we could put just A and D. So this is a sine graph. This is a sine graph. And I'll actually write the word sine because it's just a E. So it's just your y-intercept and the midline, which means that the other 2 have to be cosine. Cosine is at a maximum or a minimum. If you're like, wait, that didn't happen, it actually did. Here's your cosine graph from the first page. It started at a maximum. So that y-intercept was a max. So here's a maximum for this one. Here's a minimum. These are cosine. That's all. Let's look at the next section. Next section is talking about amplitude. So this might be a new word for you guys. It's not talking about music per se, but it does kind of relate. But for amplitude, this is talking about the distance from your midline to your max or min. So we need to figure out how far it goes from that orange line, either up to the maximum or down to the minimum. It doesn't necessarily say to use that minimum, but I think it's okay to do. So in order to find your amplitude, you're going to find the midline, which we've already done, and you're going to count how far the center line is to your maximum. So for letter A, Chelsea, my midline is here. If I'm looking at this point where my finger's pointed, how far will it go to get to your maximum? 1 unit where? Up. Technically, it'll go 1 unit down as well, but that'll work. It's just 1 unit up. So my amplitude is equal to 1. That's it. Yes, ma'am. There's literally no difference because if you go down, it's still going to be 1 unit. You just always want this. Whoa, I didn't mean to scratch it out. You always want this answer to be positive. That's why they're telling you to go to the maximum, because up usually means you're going to have a positive answer. There's one other thing I'm going to write before I answer Joseph's question. I'm not going to write amplitude all the time. I'm just going to put an A because I don't like writing that. Go ahead, Joseph. What's your question? Just leave it as the number. There is no units. I won't ask you for units. All right, for B, same thing. This one has our midline here. So if I'm going up to my unit, this is just going to be going up 1. So this is A equals 1. Chelsea, I'm sorry, I meant to ask you. For letter C, go ahead and count that. What's your amplitude? Don't worry, I'll wait. +3, good job. And go ahead and look at letter D. Positive or negative? Positive. It should always be 4, even if you're going in a downward direction. But since it asks you to just look at the maximum, it'll make it easier. You'll remember that way that it'll always be positive. You should be able to look at the minimum. Just make sure you write your answer as a positive. All right, last thing we're going to look at is finding the reflections over the x-axis. Okay, so it says look at your y-intercept. Okay, remember that y-intercept we graphed earlier? Graph it again. So all of those y-intercepts, I have them regraphed. And I'm going to zoom out just a bit, and I might zoom back in. Zoom out a little more. Okay, so in order to determine these reflections, this isn't a new term. This is just using your brain. We need to figure out which of these sines and cosines are reflections, which means they're negative, or if they're positive, which means they're just the regular parent function. So I'm going to recopy which ones are sine and cosine from that middle section we did at the top. This is sine, this is cosine, and the last one here is sine. All right, so Valerie S., can you read this first sentence for me? Read this first sentence for me. Wait, is Valerie here today? Oh, man, my bad, I need to mark her absent. All right, so it says sine should go up from the y-intercept. So for all of these, if it has a sine, sine should go up from the y-intercept. If you look at your parent function, it does that. Sine on that very first graph goes in an upward direction. Okay, so I need to do the same thing here. If I look at my sine, this graph is actually going to go up. That sine, if it goes up, that means it's a positive sign. So if that sine is going up, that's a positive. If it was going to go down, so in the opposite direction, so look up for just a second, from that y-intercept, if it would have started going down like this, that means that your graph would have reflected vertically, which means that it's actually going to be negative. Since this graph is not going down from that y-intercept, I'm just going to leave it as a positive sign. Same thing for D. D, as you go up the graph, this is literally going up. So that's going to, again, be a positive sign. Unfortunately, on this page, we don't have an option for a negative sign. But when we get through some questions next class period, we're going to see some negatives. Okay, Valeria. Go ahead and read the second part. Cosine should what? Okay, so let me stop you there. It said cosine should be at a maximum value. If you look back on that first page, cosine at a maximum value, that's where it started. So if it's starting at a maximum, it should be a positive. Go ahead and read the last part, Valeria. When it says that it's reflected vertically, guys, that means that it's negative. So for cosine, for this first one here for letter B, Fatima, what's the starting point? Is it starting at a maximum or a minimum for B? Maximum. Maximum means that your sine is going to be positive. It's a positive cosine graph. What about for letter C, Fatima? Is that starting at a maximum or a minimum? Since it's starting at a minimum, which is down here, I'm going to put a little negative sign in front of cosine. That should be what you're starting with. All right, before we move on, are there any last questions from this page? All right, let's look at the top of the next one. All right, so for the period, get your highlighter out. Okay, so with finding the period, that is going to be a little different, but it's actually pretty simple. In order to find a period, that's determining the length of one cycle or phase of your periodic graph. It says that it's also known as frequency, but I don't like defining it as frequency. I give a different definition to frequency. Frequency is the number of cycles. It's the number of cycles that occur in the interval 0 to 2 pi. So let me zoom in on that. I like to define frequency different. Frequency is the number of cycles that occur between 0 and 2 pi. So we've already identified what a cycle is, what one period is. It meets all of the points that we talked about on the first page. What we're going to do now is see exactly how many, what the frequency is and what the period is for these questions. I'm not going to do all 4 of them, but I will do about 3 out of the 4. Before we do them, I want to identify one thing first before we actually start graphing these. If you look at the graph along the x-axis, it's missing your radians. So what I want you to do is label this from 0 to pi over 2, to pi, to 3 pi over 2, to 2 pi. I would put it closer to the x-axis, but I don't want it to be too small to where you can't see it. So I'm going to recopy this exact piece for the other 3 graphs. We're definitely going to need some highlighters, so I'd probably get a few different colors because we're going to need them. Okay, the first thing I'm going to do for letter A, this is the first question I'm going to do with you. For letter A, the directions say count the number of cycles from 0 to 2 pi, and then in order to calculate your period, you're going to make that 2 pi over the frequency, which is pretty much the number of cycles. So I'm going to put F for frequency, and I'm going to put F here, so that way you know that's talking about frequency. So take 2 pi and divide it by the number of cycles. The number of cycles I just labeled is your frequency. Again, your answer for these should always be positive. Okay, so looking at the first graph, first thing I need to identify is the midline. That's what we've been doing on that last page. So if I was looking at the midline for this, Jenny, what's the equation for my midline? Y equals 0, so it's along the x-axis. Next question, Jenny. Here is my y-intercept. It's that green dot. Is this a sine or a cosine graph? It's a sine graph because it literally has the midline and it has the y-intercept going right through it. So this is going to be a sine graph, and that's literally what we just did on the last page. It went from the midline up to the maximum, down to your midline, down to your minimum, and then back up to your midline. It touched the x-axis 3 times, so it technically had 3 x-intercepts on this side. When you graph this out, again, it should have 3 x-intercepts. So let's go through this. If it's starting from the x-axis, there's 1. It'll go up to the minimum or maximum. It's going to come down to your x-axis again, so it's another x-intercept. Back down to your minimum, and then back up to your x-axis. This that I just highlighted in pink, that's 1 full cycle. It went from midline, maximum, midline, minimum, back to your midline. It needs to have 3 x-intercepts when you graph that out. Have we finished one full range from 0 to 2 pi? Yes or no? No, we still have more graph to go, so let's keep going. Okay, so all of this in pink is one graph. Let me pick a different color, and let's do it again. It's going to go from the midline up to the maximum, down to your midline, down to your minimum, and then back up to your midline. This item in green is another cycle. It went through that same curve that we saw on the very first page. All right, last part in blue. If I could get over to this point here, I'll be done because I just need to see how far it is or how many cycles you have between 0 and 2 pi. Midline, maximum, midline, minimum, back up to your midline. Whenever you're looking for sine, it needs to have 3 x-intercepts for 1 full cycle. For 1 full cycle, it needs to have 3 x-intercepts. 1, 2, 3, that's pink. 1, 2, 3, that's green. 1, 2, 3, that's blue. How many cycles did this problem have? 4. 4? 3, it had 3. So the number of cycles that it has is 3. It's the pink, the green, and the blue. So the number of cycles for frequency, f is going to equal 3. I also need to calculate the period. The period is going to equal 2 pi over the number of cycles. So 2 pi over the number of cycles, which we just said was 3. Can we simplify 2 over 3? No, this would be my answer. We're going to talk about how to use those next class to actually graph your functions. But for right now, we're just trying to identify the cycles. All right, last 2 questions. We're going to look at B and C, and then I'm done. So for letter B, first thing I want to do is identify what the midline is. So Valerie E, what's the midline? What's the equation for it? Y equals 0. So it's again the x-axis. We got lucky. I have my x-intercept up here. Valerie E, for this green dot, what kind of graph is this? Is this sine or cosine? It is cosine. Okay, so we know for sine it needs to have 3 x-intercepts. For cosine, which is on the first page, it doesn't. It only has 2. It has a maximum, midline, minimum, midline, maximum. Okay, so for cosine, to help me remember, I need to hit a max, min, max. That's what I need to get. Max, min, max, and I'll have 1 full cycle. So let's get my highlighter ready, and let's do the same thing for the B graph. I need to hit a max, min, max for it to be 1 full cycle. So we're starting at a max, goes down to my minimum, back up to my maximum. That is 1 full cycle. I'm going to grab a different color. We're going to do the same thing. We're starting at a maximum, I'm going down to my minimum, back up to my maximum. Max, min, max. That's my second interval, or second cycle. In blue, I'm going to graph it again. Max, down to my minimum, back up to my maximum. And oh look, I have one more. From my maximum, down to my minimum, back up to my maximum. Carlos, how many cycles do I have here? How many cycles? Count the highlighted parts. You have 4. When you find the period for this, this should be 2 pi over those number of cycles, which in this case is 4. Can 2 pi over 4 reduce, Carlos? And if so, to what? Pi over 2. That's it. I just want you to do this exact same piece for letter C. So right now, C is in cat. Get your highlighters ready. Find out what your frequency is going to be and the period. So go ahead and do that right now. Giselle, I haven't forgotten about you. What's the midline for this? Y equals 0. Trust me, guys, it won't always be y equals 0. And I know that I see my y-intercept is up here. Is this going to be a sine or cosine graph, Giselle? This is cosine. So, Giselle, tell me, how many cycles were you able to complete for this? Were you able to complete a cycle? No? Okay, so you have from this maximum down to your minimum. That's all. How much of your normal cycle would that be? Okay, well, that's the hard part to see because I can't tell if it's like a third or a fourth or a fifth or maybe a half. I have no idea how much of the graph I have. I do know that it hits a maximum, the midline, and the minimum. Okay, let me go back to my cosine function on the first page, and let's see what we have. Okay, on this graph, it starts at a maximum, goes to your midline, hits a minimum. Okay, that sounds like what I just did. Okay, but how much of this entire curve is that going to be? Think of it this way. This graph is broken into 1, 2, 3, and 4 sections. 1, 2, 3, 4. What I have right now with the graph on the other page, that is just the 2 of the 4 sections. Well, what's 2 divided by 4? 2 over 4 is just 1/2. So it's literally just half of the graph that I have. And you can honestly do the same thing for sine because I know it's coming up with letter D. This one as well has 1, 2, 3, and 4 sections, just like we did before. So 1, 2, 3, 4. So if I only give you like this part of the graph, that would be, for instance, 1 of the 4 sections, so 1/4. Same thing if I had almost all of the graph just down to this minimum, that would be 3 out of the 4 sections. So keep that in mind. You can use that to help you finish up this question. Either way, for this graph, max, midline, minimum, we have half of the entire graph. So that's my frequency. I now need to calculate the period, which is 2 pi over that frequency. Well, for this one, obviously, you're going to have to keep, change, and flip. So 2 pi over 1, and then flip that fraction to make it 2 over 1. Your period here should be 4 pi. If you have any questions, I need to hear your voice. Okay.